Now, so we understand the eBPF theory, we are going to spend next 30 minutes completing a lab exercise from isovalent.com. Isovalent is a Cisco company. So go ahead, log into isovalent.com and sign up. Once you have an account created, you can launch the lab, and we are going to work on getting started with eBPF lab. I'm going to go ahead and say launch, and you will see that I have already completed the lab before. However, I'm going to redo this again in next 30 minutes. Okay, so I have already earned the badge, but I'll make sure once you finish the lab with me, you are also eligible for a badge. So this is my first lab exercise, build OpenSnoop. OpenSnoop, as I have shown you, this is one of the tool in eBPF, and it actually listen to all system level calls. So what we are going to do, we are going to first create OpenSnoop package and then run it, and then we go to the next screen to run some cat command and see how OpenSnoop display or capture those activities. Right. So what here is the thing. Here have on the left side your workspace, terminal 1, terminal 2, and then here we have the instructions. Interesting thing is you can run the commands directly from instructions. So you don't have to really copy and paste, but you can simply hit run button from here. So the first one is go ahead and create OpenSnoop, and you can see to run OpenSnoop, we need Linux capability like cap BPF is required. That's mandatory. And for Linux kernel 5.8 and above. If you are below 5.8 and above, you also need cap sysadmin. Little insight here. So let's go ahead and do a make OpenSnoop. It is compiling the OpenSnoop tool for us. You can see we have the OpenSnoop binary available. So it's compiled. However, now run OpenSnoop from terminal 1 only. So I'm going to say run, and it will execute this compiled program. So OpenSnoop is running. OpenSnoop will now show output of each time a file is being opened. So to do simulate some activity, let's go to terminal 2, and here we are going to run a cat command which will show what is our operating system release looks like. Cat etc os-release, and you can see we have Ubuntu 24.04. This is a long-term release and regular output here. So we have OpenSnoop running in terminal 1, and immediately we'll go back to terminal 1 to verify. Yes, you can see again we have etc os release. So we have done all the instructions completely for task 1. Let's go ahead and say check, and you can see this task completed successfully. Let's go to the next task, a deeper look into eBPF program. Here, what we are going to do, we have terminal and editor, but no terminal 2, because we are going to just review one of the tool. So here you can see we have read ELF to examine the BPF object file we built earlier as a part of make command. And what we built OpenSnoop. So I'm going to execute this in terminal 1, read ELF section detail and our OpenSnoop. And the object file is in ELF format. ELF stands for executable and linked format, and it represents a common standard file format for executable file, object code, shared library, code dump, etc. Here you can see we have some trace points available like syscall and sysexit and all those things. And what this task is telling you that if you go to editor and open this file, this which is responsible for this OpenSnoop program, you'll find similar entries because it's reading it from here. And all the trace points, they are preceded by this SEC macro. So we can go to editor, go to that particular program. And here, once the program is loaded, you will see SEC and the trace points. That's how you can read the source file. This is a little bit more detail about what this system calls are doing. But we know how to correlate between the program and the compiler file. So this is good. I'm going to say next, and this is a success. Let's move on to the next task. The task is loading quickly and start here. Use BPF tool to see BPF program loaded into kernel. So now you know how to compile a program, but then we will use a few command to understand how to verify what is running. So in terminal 1, we are going to say BPF tool program list, and it will list all the BPF program here. Right now, nothing, we have not executed anything from user space. So this is all CG group, SKB and CG group devices. Think of it like a by default or system level thing. It's running all the time. Then what we are going to do, we are going to go to terminal 2 and run our custom command, our custom program, that is OpenSnoop. So you can run it from here. So OpenSnoop is running. Now let's verify what has changed. Let's go to terminal 1. I'm going to put some space here and then say rerun that program, BPF tool program list. And this time around, earlier we had only till 77, everything with CG group. However, now you can see after 77, we have 111, 13, 14, and so on, and they all are trace points. So they are custom hooks. Okay, that's what this task is asking you to check. These are actually program IDs, and then I mentioned BPF map. BPF map used as a temporary storage. So now we can run another command, BPF tool map list. And here you can see we have different map IDs, and it is related to the program OpenSnoop. So these are the different OpenSnoop dependencies with their map ID. So we learn about two commands, BPF tool map and BPF program list. That comes handy. Okay, here is some explanation. Observe that the hash table with the name start and perf event name, these are defined in source code OpenSnoop.bpf. This is coming from there. Let's look at the bytecode one of the program. So what you can do, you can actually run this BPF tool program list again and pick one of the trace point, because we know when we run OpenSnoop, some of the hooks get deployed. So let's pick up one of the trace point, and this time around, I cannot do a run because the output differs. So I'm going to copy, and we are going to double click on one of the trace point. For that, let's do BPF tool program dump xlate ID, and we can pick one of the ID from the trace point, not the CG group, but the trace point, 111 linear. And it gives you all the details here. And one of the most important thing what we are interested in is where in compiler it is mentioned. And you can see it comes from opensnoop.bpf.c line number 57. So these trace points is defined in our compiler code. And let's go to OpenSnoop BPF again, and on line number 57, the same thing, this trace point is coming from this source file. This is how you can expand or double click where this is referenced in the compiler code. So this is good. We know how to map a command or output of the command to the compiler code, because next we are going to edit the compiler code to create our custom hook. Now write our own code. Let's go ahead and say start. Add your own trace message. So what we are going to use, we are going to use a trace pipe. This is again a system level thing. So it traces, or anything coming into debug, it comes to trace pipe and you can print it. However, this is not very production friendly because of there it has certain limitation. In production, you should actually be using BPF perf output. However, for testing purposes, we are going to look at this trace pipe. Okay, so let's go ahead and in editor and change a compiler code a little bit. So we are again going to stick to opensnoop.bpf.c. So let's go to editor, find that compiler code, and this time around we're going to change it a little bit. So find cleanup. There's only one cleanup here. Here you can see 156. We have cleanup, and it is asking us to add BPF print K, hello world. I'm going to print this just above the cleanup as it's shown here. Make some space, and this is saving. Changes saved. Now this part is done. If you're running Windows, you need to fix end of the line, but we are not running Windows, so we are good. Now let's go to terminal 1 and do the same exercise. So we are going to compile OpenSnoop because we have changed the code a little bit. I'm going to just do a run, quickly compiled, and then let's go to terminal 2 to see the trace pipe, what is coming in the trace pipe. See, we have compiled the OpenSnoop, but we are not running it yet. So let's go to terminal 2 and see cat sysctl debug tracing trace pipe. Right now, there is no output because it's waiting for data. And now let's go to terminal 1, execute this OpenSnoop so that it can catch those debug messages. So what we can do, we can now go to terminal 2, and you will see it is for all system calls, it is actually creating this hello world. So if we had another terminal 3, we can go ahead and do cat Etsy OS release to initiate some sort of activity, and we'll see more hello world coming in. So right now we are not doing any custom commands. That's why it's printing as and when we have something, some activity going on. So this looks good, and we can go ahead and say check. So we modified a compiler code just a little bit to see how it works. Now we are at the final stage where we'll first do a eBPF getting started quiz, and then a final lab exercise without instructions. Let's select all the correct answer. The funny thing is, it doesn't tell you how many you need. Out of 5, if I happen to select 4, it says not quite right. Too many answers provided. That means you don't need 4 for sure. Let me just say 2. And right now we are not answering. We are just checking how many exactly we need. And it says not enough answer provided. So 2 is not enough. 4 is too many. That means we need 3. Okay, cool. Now let's go ahead and answer this. Success. Yes, so BPF uses exchange data with user space and kernel space. The final challenge exam, start. And here is some exam instructions. This is pretty straightforward exam. What we are going to do, instead of OpenSnoop, we are going to compile another program called bash read line, and then use command like bpf tool program list, bpf tool map list to get more detail about that program and input that in our answer.yaml sheet and go ahead and say check. All right, so let's do that. In terminal 1, we are going to do compile bash read. But mind it, there is no copy or run here. So you need to remember what you have done previously. That is make bash read lines. This is compiled, then launch. For launching, we are being in the same directory. We are just going to say, okay, execute this. And bash read line is running. Then use bpf program list in second terminal. So while bash read line is running, go to terminal 2 and run this bpf program list. And here we need to find our program. Here you can see PID is bash read line. That means this is our program. That's what we are interested in. Okay, now let's go to editor and try to fill in the answers. Answer.yaml. And here it says program. We need some information from program, and then we'll need some information from map ID. So let's knock down the program first. Here you can see the name is already populated. It need ID, type, and tag. Let's go to terminal 2. The name is already populated. It need ID. ID is 169, and tag is this one. So let me copy the tag because I can remember the ID. That is 169. 169. Type is within quotes, this one, and the tag. Oh, that was actually tag that I copied. My bad. So this is actually a tag. So what is type? Let's see. Type is kprobe. All right. So we have details about the program, and now let's go and double click with map. So we are going to go to terminal 2. I'm going to